In this video, we will be looking at using graphs of lines. By the end of the lesson, you should be able to solve a linear equation graphically and be able to differentiate between solving an equation and evaluating an expression. So let's get started. Number one, given the graph of y equals x minus 3. So this graph right here represents the equation y equals x minus 3. Before we start to answer any questions, let's also fill in our table down here so we can get another representation of what this graph represents. So we have our graph, and as you notice, there's one point highlighted here, but we also have several other points that make up this line. Now there's more points in between here, but we're only going to focus on the one where there's an exact cross and we can look at an integer number. So if we go from our leftmost point here, when x is negative 2, let's fill in. When x is negative 2, y is 1, 2, 3, 4, 5, negative 5. And we can continue to fill this in. When x is negative 1, y is 1, 2, 3, 4, negative 4. When x is 0, y is 1, 2, 3, negative 3. When x is 1, y is negative 2. When x is 2, y is negative 1. When x is 3, y is 0. When x is 4, 2, 3, 4, y is 1. And lastly, when x is 5, y is 2. We see we have a linear pattern represented by a graph and now represented by a table. So let's answer our question here. A, what is x when y is negative 1? This question wants to know when the value of y is negative 1, what is the value of x? So let's first take a look at our graph and find when y, remember that's this axis, x and y, when y is negative 1, we come over so we can see what value of x, and we find that x right here, we go up to figure out what x is. X equals 2. We can tell that from our graph. We can also see and look at our table. The question asks when y is negative 1. So I go down here to y is negative 1, and here's my 2. X equals 2 when y is negative 1. So now if we look at solving the equation, x minus 3 equals negative 1. Remember, our graph is the graph of x minus 3. And it said here that y equals x minus 3. So if y equals x minus 3 is the same as y. So this really says y equals negative 1. And we're solving the equation. So when y equals negative 1, well, that's the same thing we just did. X equals 2. We can use our graph and our table to help us solve the equation without doing it mathematically. Now you may recall how to solve this equation. X minus 3 equals negative 1. We add 3 to both sides. X equals negative 1 plus 3 is 2. So you can feel free to check your work, but for now we want to be using the graph and the table to help us figure out and solve that equation. But you can always check your work using the algebra because they should match. Letter C. What is x when y is 0? And also, what is this called? So again, we can look at my graph. We want to find when y is 0. So when y is 0, that means we didn't go up or down. We are right here. So this is when y is 0. So what is x? 1, 2, 3. According to my graph, x is 3. Let me also check my table. If I go down when y is 0, it looks like that also confirms it. X is 3. We talked about this in one of our earlier lessons. What is this called when y is 0? When I'm on this axis, well, I take a look, I'm on the x-axis, so this is called the x-intercept. When y is 0, that's my x-intercept. I am on the x-axis. And we can look at this in the same way we did our earlier problem. We solved the equation x minus 3 equals 0. Well, remember, x minus 3 is my graph, so this is the same as y. When y equals 0, I want to solve and figure out what x is. Well, I can look at my graph again. When y equals 0, x equals 3. We're going to now turn to the back of your page to look at some definitions and take a look at another example. So let's look at this. Solve an equation means to find the missing value. When we solve an equation, we are looking to find a missing value of the variable. That's when we are solving an equation. Let's look at the difference here between evaluating an expression. So when we evaluate the expression, we're substituting a value for a variable and simplifying. So these are two different processes. So when you look at the directions for a question, determine whether you are solving or you are evaluating. Let's look at a few examples. Number 2, given the graph of y equals negative 1/2 x plus 3. So that means that this graph is represented by this equation. And let's also take a look at a table like we did in our first example by looking at where my line crosses some integer points on my grid. And just like last time, let's go ahead and plug them in. I'm going to go from left to right. So my leftmost point here is at 1, 2, 3, 4. When x is negative 4, y is 1, 2, 3, 4, 5. I don't have a nice crossing here. There still is a point there, but I'm only going to focus on where there's nice integer numbers. So I'm going to go to the left 2, negative 2, up 1, 2, 3, 4, positive 4. Now I'm sitting here when x is 0 and y is up 1, 2, 3. X is 2, y is 2, and when x is 4, y is 1. That's just making a table of the integer points on my graph. So let's take a look at answering some of these questions. What is y when x is 4? So in our earlier examples, we were given y and asked to find x. Now we're given x and asked to identify what the y value is. So I can go ahead and look at my graph. When x is 4, 1, 2, 3, 4, go up. And there's that point when x is 4. My y, I come over here. My y value is 1. I can confirm that on my table too. When x is 4, so I find x and I go down 4, y is 1. Now I'm asked to solve the equation. So letter B, I'm going to solve the equation. So now here, if you notice, this looks a lot like my original equation, except instead of this x, I've replaced it with this 4. So I'm substituting in this 4, but I want to solve. I want to know what does y equal when x is 4. So I can do the math here. Y equals negative 1/2 times 4 is negative 2 plus 3. So y equals 1. Solving the equation. Versus if we look at C, so B says y equals 1. C, I'm going to be evaluating the expression. Now notice the difference here. My expression does not have a y equals. This means it's an equation. This means it's an expression. So what I have here, I'm going to replace is the value, evaluate. I have the value of 4, and I'm going to do the same math, -2 plus 3. So I get a value of 1. So here my solution is y equals 1. Here my solution is just 1. Equation, solving an equation versus evaluating an expression. Let's take a look at one more example. Find y when x is 0. What is this called? So again, I go when x is 0, and I want to know what y is. So I go up 1, 2, 3. So from my graph, I can see it's at 3. Y equals 3. Let me check it on my table. When x is 0, y is 3. That seems to match. Let's go ahead and solve this equation again. So I can solve this. Y equals, remember that 0 times any number is 0. So I have 0 plus 3. Y equals 3. That matches. Oh, we did not answer our question here. What is this called when x is 0? Well, when y was 0, this was our x-intercept. So when x is 0, we call that, if you see where this point is sitting, it's on my y-axis. That is my y-intercept. Okay. So we see here when we solve the equation, we had y equals 3. And now when we evaluate the expression, 0 plus 3, I get the value of 3, my difference between solving and evaluating. We will continue to look at more examples and representations in class.